So those of you who are still here for this, we're now going to talk about a way in which you can modify the hydrobromination, as I've shown you right here, so that you get the so-called anti-Markovnikov product. Now on the last movie we saw that if we take but1ene, then so you've got carbon-carbon double bond, you've got two hydrogens on one carbon, you've got an ethyl on the second carbon, so this carbon, carbon 2, is more substituted. Then what we found in the normal hydrobromination was that we make the molecule that has the bromine on that more substituted carbon. We would make 2-bromobutane, we wouldn't make any 1-bromobutane. However, if you do this reaction in the presence of hydrogen peroxide with some light, okay, well then what happens is that you don't make any of the 2-bromobutane, you make the anti-Markovnikov product, in other words the one that you don't expect, in which the bromine adds to the less substituted carbon. No hydrogen peroxide, 2-bromobutane, hydrogen peroxide and light, 1-bromobutane. So the mechanism of this peroxide anti-Markovnikov reaction, well, you might have got a little clue when I told you you had light, because you've seen light before leads to a homolytic cleavage of a bond in which one electron from the bond goes on to each of the atoms that were bonded. You saw this before with the Cl2 or the Br2 when we shine light on that to make the chlorine radical or the bromine radical. What we make here is we make two hydroxy radicals. Now that hydroxy radical could bump into an HBr molecule. And if you remember the bromide radical, that's a pretty decent radical. So what happens is that the electron from the radical goes with one electron from the HBr bond. So now we got a bond between the hydrogen and the OH. And now the other electron goes from the bond to the bromine. So we make water and we have a bromide radical. Now bromide radicals, of course, like to attack things. They're very reactive. So here's our bromide radical, comes up to that double bond. Okay, bromide radical wants an electron. Here we got extra electron density here. So that bromide radical comes up like that and it says, I've got an electron, can you give me an electron? So here we've got a carbon-carbon double bond. The double bond part, right, the pi cloud homolytically splits. One electron goes and makes a bond with the bromine. The other electron goes to the other carbon, making a free radical. Okay. Now again, which carbon is going to happen? Either the bromine comes on to carbon 2, leaving carbon 1 with that free radical, or the bromine goes on to carbon 1, leaving carbon 2 with the free radical. Right, 2 electrons in this double bond here. One goes to bond with the bromine radical, one goes onto the carbon, making a carbon-based free radical. Well, what do we have here? A radical mechanism now instead of the carbocation mechanism. We have a primary radical in which the bromine went on carbon 2. We have a secondary radical in which the bromine goes on carbon 1. Which radical is better? The secondary radical. So this is the one that's going to be doing the reacting. Okay, so now it's carbon 2. Carbon 2, that's the reactive bit. Carbon 2 has that free radical, just like carbon 2 had the carbocation on it. But now, another HBr comes up. Again, Br quite happy to be a radical, so we get homolytic cleavage again of the HBr bond. One electron goes to the bromine atom, one electron goes with the hydrogen, pairs up with the extra electron, the radical here, showing little arrows there, right? One electron there, that radical electron there, one electron from the bond goes on to the bromine. And so we make another bromide radical from there. Much more interestingly though, now the hydrogen bonds on to carbon 2. So what's our product from the secondary radical? Well, the secondary radical already had the bromine on there. The secondary radical is going to be reacting to get a hydrogen. So we've made from the secondary radical 1-bromobutane. That's the nice product. We didn't make any of the 2-bromobutane because in this case the 2-bromobutane would have come from the much less stable primary radical. Markovnikov hydrobromination, that's what you see in A-level. Anti-Markovnikov hydrobromination using peroxide with light as an initiating step for the reaction, thus the reaction goes through a radical mechanism.